Today we're going to be talking about arguments. So an argument consists of two parts: the given statements, which we call the premises, and a conclusion. So here is an example of an argument. So premise 1 would be, I study for 3 hours or I fail the exam. Premise 2 would be, I did not study for 3 hours. And then our conclusion would be, therefore I failed the exam. So let's analyze this in symbolic form. I study for 3 hours, that I will call our P, and I'm going to write that down here. I study for 3 hours. P. Or, so that is going to be a disjunction. I failed the exam, so that's going to be our Q, P or Q. And the Q is I fail the exam. So our premise 2 is I did not study for 3 hours. I did not, so that's a negation of P. And then our conclusion is therefore, and the notation we're going to use for therefore is 3 dots in a triangle. Therefore, I failed the exam, and that would be Q again. So I really only have 2 independent statements. P, I studied for 3 hours, and Q, I failed the exam. Now, with our premise 1 and our premise 2, we want to find out if our conclusion is actually valid or not. So let's discuss what a valid argument is. So an argument is said to be valid if the conclusion is true whenever all the premises are also assumed to be true. Now, just because we're assuming the premises to be true doesn't mean we don't have to go through all of the different combinations of P and Q being true and false. We still have to do that. But if the end result, our conclusion, is true, if the premises does prove the conclusion, then we can say our argument is valid. Now, an argument is not valid, or we call it an invalid argument or a fallacy, if the premises don't lead to a true conclusion every single time. So in order to test this, we're going to use our truth tables to test the validity of this argument. So I'm going to use the same P and Q that we just talked about to find out if our conclusion is true. So our first thing that we need to do is find not P, which actually is our premise 2. So I'm going to take the P column and negate it, so that's going to be false, false, true, true. Next, I want to do P or Q, which is actually premise 1. So for the or disjunction, we know that the rule is false only when both is false. So I'm talking about the first 2 columns. True, true, that's true. True, false, that's true. False, true, that's true. False, false, nope, that's false. The only one that's false is when both the P and the Q are false. So what I have to do now that I've got premise 1 and premise 2 organized, now I actually have to take premise 1 and premise 2. Because to test for validity, we have to make sure that premise 1 and premise 2 are both assumed to be true, so that's an and or a conjunction. So I am going to take the second column and the third column. Those are the ones I'm focusing on, and I am going to do a conjunction between them. So for and, a conjunction is true only when both are true. So false, true, nope, that's false. False, true, nope, that's false. True, true, yes. When both of them are true, then we have a true. True, false, nope, that's false. So now I can erase my little highlights here. So premise 1 and premise 2, now we have the truth tables for both of those. But in an argument, we need to take premise 1 and premise 2 and make sure that those, I'm going to just call them premises, imply that the conclusion is true. So the premises imply a conclusion, which is going to be a conditional statement or an if-then. So I'm going to do if-then with the premises and then our conclusion. So our premises are in column 5 here, and then I'm going to be implying our conclusion, which happens to be Q. Remember, when you're doing it this way, you have to go 5th column to the 2nd column. So if false, then true. So for if-thens or implies, it's only false if the antecedent is true, but the conclusion is false. So if false, then true, that is true. If false, then false, that is true. If true, then true, that is also true. If false, then false, well, that is true. So it turns out that studying every single one of these cases, that all of the premises, when assumed to be true, implies that the conclusion is true. So notice that the last column is all true, all of it. So therefore, we can say that this argument is valid.